Hello everyone, welcome to my channel. So in previous videos, we already talked about a lot of things in the statistics. In this video, I will continue our topics about the statistical inference. In this video, we will start talk about the hypothesis test. So hypothesis test is also one important branch of our statistical inference. So it also uses the information in our sample to try to get a conclusion of our population. So here about the hypothesis test, actually the meaning of this is test of our hypothesis or test of our assumptions. So here, what is a hypothesis? So hypothesis is a statement of the parameters of one or more populations. So here, this one, it can be something about the value of our parameters. For example, if we assume or we think the population variance is equal 4 or the population mean is equal 7, there are all some example of the hypothesis. And also it can be some value like a guess of the range of our value. So for example, we say the population mean is larger than 10, or we say the population variance is smaller than 3. So this inequality is also an example of our hypothesis. So for this hypothesis, so if we think like we have one assumption, for example, we say the population mean mu is equal maybe 30, then that means in other words, we think if there is someone claim, say the population mean is not 30, then this should be wrong. So that means for our hypothesis, actually we have two statements. One, we call it the initial claim or our assumptions as a non-hypothesis. So for this non-hypothesis, generally we use the H0 or H0 to denote this. So to controverting with this non-hypothesis, we also have another hypothesis. The name of this is alternative hypothesis. So for this non-alternative hypothesis, we generally denote this by H1. So this is about the statement will contradict to our null hypothesis. So for our hypothesis, in general, they have some common rule about our null hypothesis and alternative hypothesis. For the null hypothesis, we generally use the equality to ask our assumption or statement. So for this one, this can, for example, we can have like the population mean, mu is equal a value. So for example, equal 30. Or if we have several populations, this can be like our first population mean is equal the second population mean. So no matter this is about one population or two populations, then we always use this equation here. So it's like they have the equal symbol here. So for the alternative hypothesis, this is some statement will contradict to our null hypothesis. So for example, if we assume our null hypothesis H0 is our population mean, mu is equal 50, then actually there is several ways to contradict this statement. So the first one is we can say, okay, now we say our alternative hypothesis is our population mean is not equal our value 30 here. Okay, so then the second one is we also can have another alternative hypothesis. So this is our mean is not equal 30, but here we say this should greater than, strictly greater than 30. And then the other is another choice for our H1 is our population mean, mu, is smaller than 30. So here we have three different cases to contradict our null hypothesis. So for all of this, they are correct one. So the only difference is for the first case, H1 is equal mu not equal 30. So this actually we call this is a two-side contradict. However, for the second and third, about a strictly larger than 30 or strictly smaller than 30. So for both of this is a one side contradict. So this is about very important two case of our hypothesis testing. So one is a two-side testing and the other is a one-side test. So if you already look at my video about the confidence interval, for our confidence interval, we also have a two sides and one side about the confidence interval. So here the idea of this is similar. Okay, so now this is about what is a hypothesis, and then what is a hypothesis testing. So the hypothesis testing is the process to decide which of these two competing statements about our parameters is true. So in other words, this is about the process to check about H0 and H1, so which is correct. So in general, what the conclusion we can get, we will say, okay, there is enough to reject H0. So in other words, we think H0 is incorrect, our non-hypothesis is incorrect, or we say we accept it. So this is about the process of our hypothesis testing. So now we know what is a hypothesis and what is a hypothesis test. So the next thing is how we can do this, how we can draw a conclusion about which one is better or which one is correct. So the idea is we try to check about if we assume the H0 non-hypothesis is correct. Is there something so weird? Is there something so unlikely to happen? So if the answer is yes, so that means some weird thing is happened. Then what we will do, we will reject our non-hypothesis H0. So in other words, we say this is impossible, our assumption is wrong. However, if the answer is no, so that means when our H0 was correct, when we base on these assumptions, we find, okay, everything looks so good, everything is nothing weird happened. So in this thing, what we will do is we will say we can accept H0. Okay, or in other words, actually we don't have enough information to reject our H0. So this is the idea about what we will do to check about our hypothesis. So based on these ideas, what we can do, in fact, by the hypothesis test. So the first thing is what we will do is we will get like whether or not parameters value was changed. And also we can use this hypothesis to check about some theorem or models. And the last is we can confirm the testing. So now let me give some more step by step about explain how to do a hypothesis test. So the first step we should do is we should decide what is our hypothesis, right? So that means, in other words, we need to decide what is our H0 and what is our H0. So for example, here I can say my H0 is still about the population mean. So I say this is our population mean is equal 30. And then to contradiction about this one, so my alternative hypothesis H1. So this I use a two-side test. So that means here I assume that H1 is our population mean is not equal 30. So now I already decide what is my my assumption. And then the next step is I need to try to find a test statistic. So for this test statistic, what I choose generally is based on our hypothesis. So that means we will check the value of our test statistics. So if the test statistic value is so weird, then we say, okay, our H0 is wrong. We should reject it. However, if our test statistics value is so normal, then we will claim, okay, we can accept our H0. So here for the population, if we say the population mean is equal 30, so a reasonable statistic test we can test the statistic we should find is about our sample mean. So it's about our X bar. So here, what's the idea is like if we say the population mean is 30 and our test sample mean, our test statistic is like 100. So you will say, okay, there's something weird, right? If the population mean is 30, however, our sample mean is 100, it's so away from each other. So we can say maybe our assumption about our population mean, the mu is equal 30 is not correct. So we should reject it. So that's why the test statistic is always corresponding to our hypothesis about our H0. Okay, so this is second step. And third step is we should specify a critical region. So for example, if we say, okay, now if our sample mean is maybe between 25 to 35, then I say, okay, this is a normal. I think this is a normal case for our sample mean. Or if you can say, okay, if the sample mean is between maybe 20 to 40, it's still, I feel it's reasonable to give an assumption of our population mean is 30. So this critical region is based on a given critical level or critical value. So here, if we require is a really strict or accurate, that means our critical value can be really make this range or this critical region is really narrow. So maybe just one on left of 30 and one on right of 30. However, if our critical value is not that strict, then what we can say maybe 5 on left, 5 on right about our 30 is so this 23 to 25 to 35 is also a good critical region. So this is based on the accurate about our major or our problem. So the last one of this one, this is about compute about our sample mean or compute about our look at our data to compute this test statistic. So of course about this one, what we should do is compute our sample mean here to get the value of our X bar by our data. Okay, so this is about the steps of the how to do a hypothesis test. So here I want to give a little more information about if we give a critical value, then how we can decide the critical region here. So for example, what I do is let's we talk about the two-side test first. So if we have a two-side test and we give a critical value denoted by alpha, and also we given our H0 and H1. So here the value of our, for example, this if our H0 is a mu equals 30, then the H0 value here means this is a 30. Okay, and then the critical value, what this mean? This means what we should find is find a symmetric interval with respect to our H0 value. So like on the left and on the right. And then the probability of our population, the test statistic inside this region, the probability of this is equal 1 minus alpha. So for example here about this one, if you assume the distance on the left and on the right with respect to our H0 value is as A, denoted by A, then the left endpoint of this interval is 30 minus A, right? And the right endpoint is 30 plus A. So then for this question, because our null hypothesis is about population mean, then the test statistic we should choose is about the X bar. So then for this question, it means the probability of our test statistic X bar between the left endpoint and right in the point of our critical region. This probability should equal 1 minus alpha. So now you can see when we given the value of alpha, so generally this is about some small value. So sometimes we choose this as 0.1, sometimes we choose it even smaller, 0.05 or even 0.025, some small number. So if we choose this one, then that means on this case, the left-hand side of this equation, this is equal, the probability is equal about 90% or 95% or 97.5%. So this is how we can compute about the critical region based on a given critical value. When we decided or be given the critical value here, we can use the information we have about our population, about the distribution of our test statistic to compute the left endpoint and right endpoint of our critical region. Okay, so this is about a two-side critical region, right? So if we compute about one-side critical region, what should we do? So for a one-side critical region, of course, this is still a region with respect to our H0. So that means here, if we denote this H0 value here, this is depends on what is our H1. So if here the H1 is a mu smaller than 30, if this is our H1, then what we should do is we should find a critical region about. So that means we need to try to find a left endpoint of our critical region. So this will give us the probability of our test statistic x bar is greater than this value should equal our 1 minus alpha. So in other words here, this will give us about the if we say this is our left endpoint, and then the probability on the right is about 1 minus alpha, the probability to the left is about alpha. So in the previous two sides test, so this is the probability inside this interval is 1 minus alpha, and the probability outside on the left and right is, because it's symmetric, this is give us alpha over 2 on each side. Okay, so this is explain how we can use the steps to do a hypothesis test. So in next video, I will talk about when we do the hypothesis test, there are two important types of errors, and they also have important value about p-value. So please subscribe this channel and see you in next video.